Hey, hello, and welcome to today's GFG problem of the day, symmetric tree. Okay, let's see what the problem has to say. Given a binary tree, check whether it is symmetric or not. That is, whether the binary tree is a mirror image of itself or not. So, so what do we mean by symmetric, right? So here it is saying that the tree has to be mirror image of itself. For example, if you see this example, right? So 5, see, so the left subtree, okay, needs to be the mirror image of the right subtree. Okay, that means, see, if you see 1 1 here, right, 2 2, so this is symmetric because the left subtree matches with the right subtree. Similarly, we see, let's see another example here, the left subtree 10 10 20 20. So here the one of the node is 30, right, which is not equivalent to the its left hand side right node. Okay, so this is not symmetric, or this is not mirror image of itself. So what would have been the mirror image of itself? For example, let's say yeah, this, if we take this example, right, 10 10, right, and then if it was something like this, here 30 and here 20. See, this tree is a mirror image of itself. Its left subtree, if you see it, left subtree 10 10, it is equivalent. Then its left this right left child is equivalent to the right child of 10, right? So it's mirror image, right? And 10, it's the right child of 10, that is 30, is equal to left child of 10 in the right subtree, right? Right? This 30. So this is mirror image of itself, right? Or symmetric, we can say. So this problem becomes mostly like similar to yesterday's problem, only the trick is, right? So let's see what the trick would be. So let's say if we have a symmetric function, right, is symmetric, what we'll just simply pass is symmetric helper will pass this root, right, this tree 2 times to this, okay, uh, right, 2 times, right, and we'll just return, and we have to tell, right, whether it is true or false, right? The same tree will pass it twice, and what will be the implementation of the symmetric helper? For example, whatever it is, bull is symmetric helper node root 1, right, and node root 2, right? So the trick here is, we are treating the same tree as 2 trees, right? We are passing twice, right? So here so here let's quickly see what will be the base condition. Root 1 equal to null, and root 2 equal to null, right? If it is a case, we'll simply return true, because, right, both it is same, right? For example, if we go 1 2 and 3, this is the tree, right? And if you're going left, right, we are passing the same tree again, left. The left of it is null, right? Null. If you go to the left of 2 for both the trees, it is going to be null. So this means, yes, it is symmetric, we can say, right? Because on both the like for on the left side of 2, right, for both the trees it is null, right? So we'll simply return true. If it is not the case, if for example, if 1 is null, if root 1 or root 2 is null, that means it is not symmetric, because either, both has to be same, not either, right? So we'll simply return false. For example, right, for example, if it is what do we say, uh, yeah, if it is, for example, here it was 2, right, and here it is 3, and here it is null, we don't have anything over here, right? So when we go to the left hand side, right, when we go to the left hand side of both these nodes, here we'll get 3, but here we'll get null. So this is the case, so we'll return false, it's not symmetric. Okay, then similarly, if root 1 dot data. If root dot 1 data is not equal to root 2 dot data, right? Root 2 dot data will return false again, right? The values has to be the same. For example, uh, for example, if this was the case, right? 2, 2, then 3. It was 3, for example, and this is 4, and this is 4, and this is 5. So when we go to these nodes, right, root 1, root 2, when we go to these nodes, right, so this has to be equivalent, this has to be same, but it is not the case. Root 1 dot data is not equal to root 2 dot data. So it will return false. Now the trick here is, see, where now if everything is good, right, everything is root 1, root 2 data is same, then what we'll do, simply return, then we'll call again this, right, recursive function is symmetric helper. See, symmetric helper, the trick here is will pass root 1 dot left and root 2 dot right, right? Root 2 dot right. Because we have to check for the equivalent, right? The left and right subtrees has to be the same, right? Has to be the mirror image. So what is making sure? We are making sure over here, right? Root 1 and root 2 data is true. Root 1 and root 2 both has to be null at the same time, right? Is symmetric helper and then. So the left subtree of, right, the left subtree and the right subtree has to be same. Is symmetric helper again, helper. So this is the trick. Root 1 dot right this time, right, and root 2 dot left. So, right, root 1 dot right and root 2 dot left. Once root 1 dot left and root 2. So this is the main trick, right? We are passing the same tree, but we are passing the left and right subtrees in order to check the symmetric, whether it is symmetric or whether it is mirror image of itself, right? So let's see the code now. If you see the code, right? So here we are passing is symmetric helper root comma root, right? And then what we are checking, as I said, right? We are checking the base condition. Both has to be null. If it is null, then return true. Then either of them, if it is either of them is null, then it's not mirror image. We have to return false. And also the data has to be the same, right? On the left and on the right side, the data has to be the same for it to be called mirror image. And then simply symmetric helper we are calling root 1 dot left we are passing along with root 2 dot right, right? And once we are passing root 1 dot right and root 2 dot left. Okay. So this is the solution. Let's submit it and check. Yes, it is accepted. Also, we are adhering to the time complexity. That is O of n, right? Because we are iterating all the nodes to check the mirror image, right? To check the mirror image. And height of tree, we are using the functional stack, right? Which takes O of height of the tree. Okay. So this is a solution. I hope you have understood. Please like the video and subscribe to my channel. Thank you so much.